Thank you everyone for taking the time to join us. Today we are here to present our top 100 households to contact from a prospective customer list that was provided over to the team. And before we get started, I would like to give everyone on our team a chance to introduce themselves. Personally, my name is Ryan Mahalam.
I'm Samaya Ghaibi.
Hi, this is Iraj Akhtar.
And Mark Skovic.
Great. So this is the program that we followed throughout the case study. Specifically, today we will be reviewing a deep dive into our data modeling and interpretation. Next. We were provided over historical data from our customers in National City, and our goal is to ultimately identify the households with the greatest probability of accepting our offer if and when we would send it out to them. So by examining historical data, bringing in other third-party data, researching and comparing different models, we were able to generate a list of 100 potential customers for a National City. Before we move forward, I would just like to note our stakeholders for this project: the chief of product, our executive team, as well as our marketing and sales teams. We appreciate the partnership and continued support. For now, I will pass it over to Samaya.
In order to find our top customer, we used our existing internal data and combine it with the external data we could find publicly, such as public information in credit bureaus or public vehicle purchase information, history, or public household demographic to assist us to find our top customer. So for this project, we have targeted our effort as a binary classification problem, and we create a model to be able to identify our prospective customer. Next. We create a model that will use existing data and apply to our prospective customer to predict each customer's likelihood to accept an offer for a used vehicle line of credit. This task only predicts the likelihood of two outcomes: accepted or did not accept. The binary classification will be used to create a list of the top 100 prospective customers most likely to accept the offer by sorting customers by the highest probability of an accepted prediction. Next. To be able to use this model, we need to take different steps. The first step is EDA, and which include the feature selection and also treatment of data to create dummy variable for categorical data and impute any missing value. Then we partition our data and split it to separate training and test set by randomly selecting a desired number of observations for each group. Training data is used to develop model parameters, which are then evaluated on test data that the algorithm has not yet seen. We tested different partitioning, such as 50-50, 60-40, 70-30, to select the best outcome for our model. Now, Iraj will continue.
Hi, Iraj here. In executing this data mining project, we used a multiple model approach that iterates several instances and variations of select algorithms. We cycled through several statistical modeling and machine learning techniques to get to one top performing model. Our team ran random training partitions through logistic regression, k-nearest neighbor, decision trees, random forest, and boosted tree models. As you can see in the bottom flow diagram, we computed several iterations of each model to arrive at a composite average accuracy score. And then based on this metric, we selected the best model for performing this task in actual practice. This graph here highlights our multiple model approach to this problem set. We arrived at a range of training and test accuracies. Training models performed from 0.69 accuracy to 0.81, and test models range from 59% to 76% accuracy. Based on the average performance of each model, we determined that Random Forest had the greatest prediction accuracy in both training and test models. In selecting our model for production, we wanted to have a high degree of trainability and a high degree of validity for the greatest success in real life. The Random Forest creates many decision trees and identifies one majority decision tree path to an output that will divide data entries into different groups of predictions at each decision node. This type of tree-based machine learning approach uses the wisdom of the crowd, or the law of averages. To execute our production model, we tuned our Random Forest parameters to perform 100 iterations, with each tree branching 5 nodes. With this, our error rate improves substantially at around 20 runs. As the number of trees iterate, the model error rate improves its performance based on prior outcomes. The best performing model trained at 93% accuracy and validated at 76%. As such, we expect 76% of any targeting list to respond and successfully to our predictions.
Here we can get a better idea of the results. We ran our best Random Forest model, and a way to interpret the most important variables come from this chart on the left. So these are the most important variables in determining our outcome variable. In this case, these are the most important variables to determine whether a prospective customer is likely to accept our offer or not. The most important variable with the highest importance score here is derived from the car model predictor variable. Next up is customer age, and third is contact attempts. On the chart on the right here, we can see customer age represented in a different way, showing the predictions for accepting an offer based on a prospective customer's age. In the red, you see higher likelihoods to accept the offer, and the blue, cooler colors, you see lower likelihoods, and you can see the group with the highest likelihood to accept the offer for this new product come in the ages between about 30 and 50. These are the highest red marks. Next. So among the top 100 prospective customers we've determined are most likely to accept the offer, we have broken down some of their demographics that you can see here. The most notable are the top 5 looking for a past outcome. Failures are more common than successes. The most common marital status is married. It is very rare that a default would be on record to accept, and most customers do not actually have insurance already or have an existing car loan. So like we said before, married households between the ages of 30 and 50 can provide sort of a representative case, sort of the average case for these prospective customers that landed in our top 100 list. Next. So you can see here a snippet of our top 100 list. This represents the top 50. These household IDs can be sorted by their probability to accept the offer based on how our model scored them. You see here the probabilities are above 95% for all of these to accept, and we would imagine these would be representative of the most likely customers to accept in real life. Once they are contacted by the marketing department, this represents this list of the top 100 customers to market to first, and this list can be used for further research and analyzing the most likely customers to accept the offer. Next.
All right. So we do have a CSV file ready to share out with everybody here. At this time, we are ready to move forward with the communications to these 100 customers. Our goal is that these 100 customers will serve as a pilot wave for ultimately a much larger effort. And once we have successfully reviewed the results on these 100 customers, we will circle back as a project team, review our models, and prepare to push out our final model out to thousands of more customers. And we really hope that you enjoyed our presentation, and we look forward to continued success with National City. Thank you.